All right, so I have three examples to show you in this video. So we're simplifying trig identities. So you want to keep your note card with your Pythagorean identities and your reciprocal identities and quotient identities available if you're just learning this topic. All right, so the first example, I notice this looks like it's coming from our Pythagorean identity that says sine squared x plus cosine squared x equals 1. Now, if I rearrange this and I go ahead and move that sine squared x to the other side, you can see how rearranging that Pythagorean identity 1 minus sine squared x is now equal to cosine squared x. So we're going to make a replacement in the denominator here. So we'll have cosine squared x in our denominator. On the numerator, I'm going to go ahead and change that to its quotient identity. So cotangent squared x. We're going to take that and rewrite it as cosine squared x divided by sine squared x. Now we see we are working with a complex fraction. Let's go ahead and take that complex fraction, rewrite it. Cosine squared x over sine squared x. I'm going to put a division symbol here, divided by cosine squared x. Now, we can keep the first fraction the same. We're going to change to multiplication. We're going to do our keep, change, flip on this. Change to multiplication, and then we're going to take the reciprocal. We're going to flip that fraction. Right now it's over 1, so it's going to be 1 over cosine squared x. Now we see that the numerator and the denominator can reduce, and we'll be left with 1 over sine squared x, which is the reciprocal of cosecant squared x. And that is our final answer here. Next problem. Now, I tried this problem a couple of different ways, and I found the best way to work this out is to first expand it. We're going to rewrite it as tan x plus cotangent x. We're going to write that out twice, and once we do that, we can go ahead and distribute, which some teachers say to FOIL. You multiply the first, outer, inner, and last. So let's go ahead and multiply the first and the outer. We'll distribute tan x to both of those terms. Tan x times tan x is tan squared x. And then tan x times cotangent x is tan x cotangent x. And let's go ahead and distribute cotangent x. And we'll have tan x times cotangent x here. And then cotangent times cotangent is cotangent squared x. All right, so now we have some like terms here. But I also want you to pay attention and realize that you've got reciprocals of one another. We have, let me rewrite this, tan squared x plus tan x, and cotangent can be rewritten as 1 over tan x. So that's all, the entire unit here is going to be replaced with 1. And the same goes for the next term, tan x, and 1 over tan x plus cotangent squared x. Here we go. So this will cancel out. We'll have 1 left over there. This will cancel out. We'll have a 1 plus cotangent squared x. And I did not forget about the tan squared x, so let's go ahead and write that in front. All right, so now looking at your Pythagorean identities, you can actually, instead of adding 1 plus 1, because it would be pointless to do that at this point, let's go ahead and replace tan squared x plus 1 with secant squared x. And 1 plus cotangent squared x is equal to cosecant squared x. And this is your final answer. All right, last problem. Okay, so we've got fractions which we want to add, and they have completely different denominators. So first we want to establish what the least common denominator is, the LCD, and it looks like it's going to actually be both of these binomials. It'll be sine x plus sine y and cosine x plus cosine y. So we want both denominators to look like this so that we can work with the numerators and start to add the fractions together. So the second fraction, I'll jump in and say, okay, well, I'm going to multiply this by sine x plus sine y. I'll do that to the denominator and the numerator as well. But on the other fraction, I don't have a lot of space here, so what I'll do is I'll just draw an arrow. I'll multiply the numerator and the denominator by cosine x plus cosine y, cosine x plus cosine y. So this is being multiplied on the numerator and the denominator right there. Okay, so on the next step, I'll make that a little clearer. So we'll have on the numerator cosine x plus cosine y being multiplied by cosine x minus cosine y. So we're going to have to distribute all of that. The denominator will say it is cosine x plus cosine y times sine x plus sine y. At this point, do not cancel out anything. We are trying to get the same denominator so that we can work with combining the numerators. Second fraction here, we have sine x minus sine y times sine x plus sine y. Denominator looks like it's going to be cosine x, same as the other one, plus cosine y times sine x plus sine y. All right. Okay, so we have quite a bit of work to do on our numerator here. We're going to distribute, same thing here, we're going to distribute, but the nice thing about this is that they're conjugates. So if you do decide to multiply the first, outer, and inner, and last, what's going to happen is that the outer and the inner is going to cancel out. Now I'll show you that with the first fraction, and on the second fraction, I'll just already establish that the outer and inner will cancel out because they're conjugates being multiplied, so I won't actually work that out. So in the first fraction, if I do work it out, I have cosine squared x minus cosine x cosine y, right, plus cosine x cosine y minus cosine squared y. So you can see it took a lot of space here, and here it is. The first, the outer, the inner, and the last. And you notice the outer and the inner are conjugates, so they will cancel out. And so in the second fraction, I'm not even going to bother multiplying the outer and the inner. I'm just going to multiply the first and the last. So I will get sine squared x minus sine squared y. And this is all over the same denominator, so we're just going to rewrite that over here. So now we'll carefully start to combine the numerators together. We have cosine squared x minus cosine squared y plus sine squared x minus sine squared y. And it's all over that same denominator. Now you can see some of these terms have the same variables in common. So I'm looking specifically at cosine squared x plus sine squared x. Those two together, that's a Pythagorean identity. That's going to equal 1. Now we're dealing also with minus cosine squared y minus sine squared y. I'm going to go ahead and factor out a 1 there. I'm going to take my time. I'm going to do a little rearranging first just so that I don't lose you here. Okay, so we're going to have cosine squared x has the same variable as sine squared x. And again, that's going to equal 1 in just a moment. I'm going to factor out the negative out of here. So I'll have minus 1. And so I'll be left with cosine squared y plus sine squared y. And that same denominator, let's go ahead and write that. All right, and we're almost done here. Okay, so what we're going to do is we're going to replace this binomial with 1. Same goes for this. We're going to replace this binomial with 1. All right, so we'll have 1 minus 1 times 1 all over this denominator. I'm not going to rewrite it over just because you're going to see what's about to happen. We'll have 1 minus 1, which is equal to 0 over that denominator, and 0 over any number over any denominator except for 0 is 0. So our final answer for this problem is 0. All right, so leave a comment if you have any questions. I'm around.